Hello everyone, welcome to my first mechanical engineering class. This course serves as an introduction where I will cover the definition, history, and fundamentals of mechanical engineering. Each fundamental aspect of mechanical engineering will be explored in detail in the upcoming sessions. What is mechanical engineering? It is the study of physical machines that involve force and movement. The objective of this course is, first and foremost, to introduce students to the fundamental concepts of mechanical engineering. The second objective is to enable students to understand the importance of mechanical engineers in system design, solving real-world problems, and driving innovation. Also to broad applications in various industries, automotive, aerospace, energy, robotics, etc. In this chapter, we will provide an overview of mechanical engineering. We will cover the scope of mechanical engineering. Also the historical development and evolution of the field. The importance of mechanical engineering in modern society and the role of mechanical engineers. Now, let's explore the scope of mechanical engineering. Automotive, design and optimize vehicles for performance, safety, and fuel efficiency. Aerospace, develop aircraft, spacecraft, and propulsion systems for commercial, defense, and space exploration. Energy, innovate power generation systems, renewable energy solutions, and efficient energy storage technologies. Mechanical engineering plays a crucial role in advancing these industries and shaping the future. Now, let's continue with the scope of mechanical engineering. Robotics, design and program automated systems for manufacturing, healthcare, and service applications. Manufacturing, optimize processes using advanced machinery, automation, and innovative materials. These areas highlight how mechanical engineers drive efficiency and innovation across industries.
Continuing with the scope of mechanical engineering, healthcare, develop medical devices, prosthetics, and diagnostic equipment to improve patient care. Construction, contribute to infrastructure projects with HVAC systems, structural analysis, and machinery. Consumer products, design efficient, durable, and innovative appliances and gadgets for daily use. These fields showcase the versatility and impact of mechanical engineering on society. Let's now look at the historical development and evolution of mechanical engineering. The field began with the creation of ancient tools and simple machines, laying the foundation for human innovation. It advanced significantly during the Industrial Revolution with groundbreaking inventions like the steam engine, transforming industries and societies. Today, mechanical engineering embraces cutting-edge technologies, including robotics, nanotechnology, and AI, driving innovation in every sector and shaping the future. Moving on, let's explore the importance of mechanical engineering in modern society. Mechanical engineering is at the heart of innovation, driving progress in transportation, energy, healthcare, and sustainability. It tackles global challenges, creates solutions for a better world, and continuously improves our quality of life through groundbreaking advancements. Next, let's examine the role of mechanical engineers. One of their primary roles is design and development. Mechanical engineers create innovative solutions for systems, machines, and products, ensuring they are both functional and efficient. Their work shapes industries and drives progress, from everyday appliances to advanced technological systems. Another key role of mechanical engineers is analysis and problem solving. They evaluate mechanical systems to identify issues and improve performance. Through optimization and innovation, they ensure systems operate efficiently and reliably, addressing challenges in industries ranging from manufacturing to energy. Additionally, mechanical engineers play a crucial role in manufacturing oversight. They supervise production processes, ensuring that products meet quality standards, adhere to safety regulations, and remain cost-effective. Their expertise ensures that manufacturing operations run smoothly and efficiently, contributing to the success of industries worldwide. Energy systems are another vital focus area for mechanical engineers. They develop and maintain renewable energy solutions, design power plants, and create energy-efficient technologies. By advancing sustainable energy systems, mechanical engineers play a key role in addressing global energy demands and combating climate change. Another significant area of focus for mechanical engineers is automation and robotics. They design cutting-edge automated systems and robots that enhance efficiency and precision in industries such as manufacturing, healthcare, and logistics. These advancements contribute to improving productivity and reshaping modern industry practices. Another important aspect of the mechanical engineer's role is material selection. They choose materials based on their properties to meet the specific demands of a project. This decision is crucial for ensuring the strength, durability, and cost-effectiveness of the final product, and it impacts the overall performance and longevity of systems across various industries. Sustainability is a growing priority for mechanical engineers. They focus on designing eco-friendly solutions and improving processes to reduce environmental impact. By incorporating sustainable practices, such as energy-efficient systems and the use of renewable materials, mechanical engineers play a critical role in promoting environmental responsibility across industries. Finally, project management is a crucial aspect of a mechanical engineer's role. They lead teams, manage budgets, and ensure that projects are delivered on time and within scope. Their organizational and leadership skills are essential for coordinating complex projects, ensuring efficiency, and meeting both technical and business objectives. In this chapter, we will cover the following key concepts: mechanics, thermodynamics, material science, fluid mechanics, manufacturing processes, control systems. These concepts are the foundation of mechanical engineering, essential for understanding and solving engineering problems. Let's begin with mechanics. Mechanics is the study of forces, motion, and their effects on objects. It includes two main branches: statics, which focuses on forces in equilibrium, and dynamics, which deals with the motion of objects and the forces that cause that motion. These principles are fundamental for analyzing and designing mechanical systems. Next, we move on to thermodynamics. Thermodynamics is the science of energy, heat transfer, and their transformations. It focuses on understanding how energy flows and changes form, with applications in power generation, engines, refrigeration systems, and more. This field is crucial for optimizing energy efficiency and developing sustainable solutions. Now, let's look at fluid mechanics. Fluid mechanics is the study of fluids, both liquids and gases, in motion and at rest. It has wide applications in fields like hydraulics, aerodynamics, and energy systems, where understanding how fluids behave is essential for designing efficient systems, from pumps and turbines to airplanes and weather systems. Next, we move on to material science. Material science focuses on understanding the properties, behavior, and selection of materials. It ensures that the right materials are chosen to meet the strength, durability, and efficiency requirements of designs. This field is essential for developing innovative products and optimizing the performance of mechanical systems. Moving on to manufacturing processes. Manufacturing processes involve techniques like machining, casting, welding, and 3D printing used to create mechanical components and products. These methods are essential for transforming raw materials into functional parts, ensuring precision, quality, and efficiency in production. Shifting focus to design and analysis. Design and analysis rely on advanced tools like CAD, computer-aided design, and CAE, computer-aided engineering. These technologies enable engineers to design, simulate, and optimize systems with precision, enhancing efficiency and reducing the time and cost of development. Finally, let's discuss control systems. Control systems involve the integration of sensors, actuators, and controllers to automate and manage mechanical systems. These systems ensure precision and reliability, playing a vital role in modern technologies like robotics, industrial automation, and vehicle systems. What's next? In the upcoming courses, we'll dive deeper into the fundamentals of mechanical engineering. Topics will include mechanics, thermodynamics, fluid dynamics, material science, and design and manufacturing. Each subject will be explored in detail, providing a solid foundation to build your expertise step by step. These courses will equip you with the essential tools to tackle engineering challenges, drive innovation, and contribute to advancing technology. Together, we'll explore concepts that empower you to shape the future. Let's embark on this exciting journey and unlock the limitless potential of mechanical engineering. This concludes our first session. Thank you for joining this introduction to mechanical engineering. If you have any questions or need further clarification, feel free to contact us. We look forward to supporting you as we continue this exciting learning journey together. See you in the next session.